Okay, good afternoon, everyone. So today we're going to talk about the turning points of a quadratic equation. Now, first of all, every single quadratic equation, okay, would have a turning point. A turning point means a point that the quadratic starts to change its direction. It's usually either the highest or the lowest point. So if you look at the red lines on this page, and the bottom point, the bottom corner here, is often referred to as the turning point. Okay, so the turning point means the graph starts to, initially it goes all the way down and it starts to go up. So the direction of the graph, the direction of the line starts to change. And this is the idea of the turning point. Now, um, the turning point, also known as the vertex, okay, they mean the same thing. Okay, if we draw a vertical line across that particular point, then we can call that the axis of symmetry. Okay, symmetry means the same, okay, and axis means a vertical or horizontal line. Now, in this case, it's a vertical one, so it goes from top to the bottom. Now, it's called symmetry because if we fold this line according to if we fold this quadratic graph according to the axis of symmetry, we would have two pages overlapping each other. Okay, so it's like a mirror image. Okay, and a mirror stands right in the axis of symmetry. Now, to find the axis of symmetry, we need to first identify the quadratic function, and we try to put it in the complete the square format. Now notice it's in the bracket sort of square format. So if we have y equal to a in the bracket x plus b and the square plus c, then we have the axis of symmetry x equal to 2b. Okay? So if we have a general form, we will need to simplify or try to put that into the complete square format first. We'll look at how do we do that. Now, if we want to find the axis of symmetry for this equation, says y equal to x take away 2 square plus 3. It is fairly easy, fairly straightforward. Remember, when we have to complete the square form, we just need to find the b value in this case will be -2. So therefore, the axis of symmetry would be x equal to -b. And we know b is -2. So therefore, the axis will be x equal to the negative or negative makes it a positive, so we have a +2. Now, if we draw that on the graph, then we would have 1, 2, and it's a vertical line goes through the second point, so that's x equal to 2. Now, the graph is going to be a little bit above the axis. Let's just call 1, 2, 3, 4, 5. So 1, 2, 3 will give us here, and then we can sort of draw the graph like a general sketch. Okay, it's not to the scale, so it's just give you a general idea. So this vertical line is called the axis of symmetry, and we describe it by using x equal to 2. Now, when we have a general form, for example, when we have this equation says y equal to x squared take away 6x plus 3, then we will need to first try to put it into the uh, form using complete the square. Now, since we have a -6 here, we need to halve it, and then we got -3, okay? And then because we would have, if we expand this one, we would have x squared take away 6x plus 9. But instead of a 9, I only need 3. So the difference of that will be 6. So I will need to take away 6 to get to that particular plus 3. Okay? So in another word, we can say that the general form can be simplified into this complete square format. Now, in this way, we can therefore say the axis of symmetry will be x equal to negative 3. So in another word, x will be equal to 3 is our axis of symmetry. Okay, now let's keep going. And once we figure out the axis of symmetry, then we can start working on the turning point. Now, every single quadratic equation would have a turning point. Okay, every single quadratic function or equation has a turning point. Now, the turning point, remember, lies on the axis of symmetry. The axis of symmetry is just a vertical line that bypasses that. So that means if we can sort of identify the axis of symmetry, so we just do, we have the axis of symmetry for this equation. Remember when we did this last time, we have x equal to 2. Okay, so to find a turning point, that means we need to plug the value x equal to 2 into this equation. So we can say, therefore, y is equal to x is 2, so 2 take away 2 square plus 3. Then interestingly, the middle one will go 2 minus 2 will give us 0. So that will be 0 squared plus 3. So that's nothing, and that's just 3. Therefore, the turning point will be just 2 and 3. Okay, so that means we have the x value equal to 2, we have the y value equal to 3. So we can have this 2 and 3. Now, a quick way to think about it is if we have an equation says y is equal to a and x plus b squared plus c. So remember, still we're looking at ABC. The turning point is going to be negative b and c. Okay, so in this case will be negative 2, so that's positive 2, and c is equal to 3. This is a quick way to sort of get to the solution of the question. Now, of course, when we have um, the general form, we'll need to first complete the square. So x take away 3 square, take away 6, because we already worked this out in the previous question, so I'm not going to repeat. But anyway, so if we have that, okay, using the knowledge we have, the turning is always going to be negative b and c. So negative b is negative 3 here, and c is negative 6 here. So the turning point will be 3 and negative 6. So always remember the first step we'll need to complete the square. And then after that, you can use this form to just tell us what's the turning point, what is the axis of symmetry. Okay, so that's pretty much the end of the slideshow. So in today's lesson, what I would like you to work on is, oops, excuse me. So there's a separate page called Turning Point and Axis of Symmetry. I'd like you to work on these questions. Now I put the question into 3 groups, the green, blue, and red. Still check which group are you in, and then you can sort of choose the most appropriate level of difficulty for yourself. Once you finish the question, you can double click the plus sign here. There's a plus sign here. If you double click, you'll review the solutions. Otherwise, it's hidden. Okay, so have a go with these questions. Find the axis of symmetry and then find the turning point. Okay.